how an energy storage system composed of 8 battery modules and a Jinlang inverter is installed and connected. Let's see. First, the battery part needs to be connected in series. 8 battery modules were used corresponding series connection of positive and negative electrodes. After the bronze plate and the cable are connected, be sure to check whether the copper plate and cable are connected firmly. Finally, multiple battery modules are connected in series to form a total positive and a total negative. Then the total negative is connected to the input negative electrode of the high voltage control box. Then connect the positive electrode. Now there is one last step left to connect and form a loop. The moment the circuit is formed, a high voltage will be generated. Therefore, do not touch metal surfaces with your hands. The power connection part of the battery system is complete. Then the communication connection. First of all, the communication connection has been connected now. Now I'll demonstrate how the communication link is connected. First, find the green terminal communication interface of the high voltage control box, then connect to the green terminal under the first battery module. Then the first one is connected to the second one. The second station is connected to the third station. Connect the fourth, fifth, sixth, seventh, and eighth stations in sequence for the series connection of communication lines. The communication part has also been connected successfully. And now open the high-pressure control box. The voltage of the battery module and the battery capacity will be displayed on the high-voltage control box. If there is no red alarm display at this time, it means that the entire battery system is normal. Now let me talk about the connection between the battery system and the inverter. First, find the 2 battery connection ports of the inverter. This is the connection port for battery 1. This is the connection port for battery 2. Now let's connect the connection port of battery 2 first. First, connect the positive and negative electrodes of battery 2. And then connect the positive electrodes of battery 2 to the output positive electrode of the high voltage control box. That's the P positive on the right. Then the negative electrode of the battery is connected to the output negative electrode of the high voltage control box, which is P negative. Okay, let's make a communication connection between the inverter and the battery system. Since we are connecting the port of battery to here, we need to find the 𝐵𝐸 to first. If you are connecting the battery port of 𝐵𝐸1, you need to connect the 𝐵𝐸1. If 2 battery clusters are connected at the same time, you need to connect them at the same time. Insert the corresponding battery cluster cable interfaces into different 𝐵𝐸1 and 𝐵𝐸2 respectively. Here, let's plug in 𝐵𝐸2 here. Then the other end of the network cable is connected to the inverter network port of the high voltage control box. At this point, the power and communication connection of the entire system has been completed. Now we want to test the charge and discharge of the battery. First, turn on the switch of the high voltage control box. Second, turn on the grid. The grid here is turned on. So when the screen waits for the screen to light up, check whether the battery has communicated normally. If the communication is normal, it will show that BMS COM is okay, and then there will be SOC and voltage display. Now let's take a look at the warning content. Here, because the mode of 2 batteries are selected, this battery is not connected. So the battery 1 has no grid, and the battery and voltage are low alarms. Don't worry about these. Then look at the setting of the time period that has been discharged in the energy storage mode. Here is the discharge time period. Here is the charging time period. Then each time period has a start time, a stop time, and the size of the charging current, the size of the charging and discharging current, and the target SOC you want. If you want to discharge, your target SOC must be lower than the SOC of the battery at this time. Then if you want to charge, your target SOC must be greater than the battery SOC at this time. It can be seen that the grid has been successfully connected to the grid, and the battery has started to discharge.